All right, let's talk about the invisible system that makes our entire digital world go round, the Internet's addressing system. It's the reason data can find you, and you can find data from anywhere on Earth in literally the blink of an eye.
I mean, seriously, think about that for a second. It feels like absolute magic, right? But it's not. It all comes down to a unique address, kind of like a digital version of your home address. This is the secret sauce that lets you stream a movie from a server in, say, California, while you're sitting on a train in Japan.
And here's what it's called, the IP address. You've probably heard the term. You should think of it as a universal postal code for every single device online, from those giant servers that run our favorite websites all the way down to the smartphone in your hand. If a device doesn't have an address, it's not getting connected. It's really that simple. Look at this comparison. It's perfect. A postal address gets a letter to one specific building out of billions in the entire world. Well, an IP address does the exact same thing, but for a packet of data trying to find one specific device among billions online. The principle is identical. Make sure the information gets exactly where it's supposed to go.
Okay, so let's zoom in a bit. The IP address gets data to your front door. That's your router. But once it's inside your house, how does it find your specific laptop? I mean, you've probably got your phone, a smart TV, maybe a gaming console. They all live under the same digital roof.
And this is where it gets really interesting. The main IP address gets the package to the right apartment building, but we still have to figure out the right apartment number. If we don't, that video you're trying to stream might end up on your smart fridge instead of your laptop. This solution is this really clever little process called ARP, which stands for Address Resolution Protocol. The best way to think about it is like the receptionist in your building's lobby. It knows how to match the temporary IP address, which is like a visitor's pass, to each device's permanent, unchangeable physical address, which is called a MAC address. That MAC address is burned into the hardware from the factory. It never, ever changes. So here's how it works in practice. The router basically just shouts out a message to every device it's connected to. It's like it's saying, hey, who in here has this specific IP address? Your laptop recognizes its own address and replies, yo, that's me. And here's why permanent physical address. And boom. From that moment on, the router knows exactly where to send the data. It's like a super fast, super efficient digital roll call. All right, so that's how it works locally. Now let's zoom way, way out and talk about the bigger picture. Because this whole system, which was designed way back in the early days of the internet, was heading straight for a massive global scale crisis that pretty much threatened to stop its growth dead in its tracks. Take a look at this number. It's about 4.3 billion. Now that is the absolute maximum number of addresses available under the original system, which we call IPv4. And that number isn't random. It's because it was built on a 32-bit design. Back in the 1970s, 4.3 billion addresses, well, that seemed like way more than humanity would ever need. But they were wrong. The architects of the early internet, brilliant as they were, they just couldn't have predicted the explosion of personal computers, then smartphones, and now the whole Internet of Things. We were quite literally running out of room on the internet. The internet was facing a growth ceiling. To keep expanding, it needed a massive fundamental upgrade. And thankfully, pioneers like Vint Cerf, one of the guys who literally designed the internet, saw this problem coming from a mile away and had already figured out the solution. And that solution brings us to the next generation of the Internet Protocol. It's called IPv6. And it wasn't just designed to solve the address shortage. It was designed for a future that the past could barely even imagine. So the solution was to move from a 32-bit address system to a 128-bit one. Now, you might hear that jump from 32 to 128 and think, okay, so it's 4 times bigger? No. In the digital world, this is an exponential explosion. We're talking about the difference between a single grain of sand and all the beaches on planet Earth. Get ready for this. This is the number of available IPv6 addresses. That's 340 undecillion. I mean, what does that even mean? To put that number into perspective, it's enough to give a unique IP address to every single atom on the surface of the Earth, and still have enough addresses left over to do the same thing for a few hundred more planets. Yeah, we are not going to run out again. But here's the thing. IPv6 isn't just about having way more addresses. It's a total upgrade. It was built from the ground up with modern security in mind, which makes our connections inherently safer. It also makes routing data more efficient, which can lead to a faster internet overall. Basically, it was designed from day one for the world we live in right now, a world of connected everything. So this creates a huge problem, right? You've got two completely different addressing systems, the old IPv4 and the new IPv6. How on earth do you switch over the entire planet without everything just breaking? This was the core challenge. You can't just flip a giant switch for the entire planet one day. So, for years, and this is still happening today, new IPv6 data packets have to travel through huge chunks of the internet that only speak the old IPv4 language. And the solution they came up with it's incredibly clever. It's a workaround called tunneling, and it's basically a way to mail a letter using a postal system that doesn't understand the new address format. Think of it like this. You take your new, complex letter with the long IPv6 address on it, and you stick it inside an old-fashioned envelope with a simple IPv4 address on the outside. The old postal system only sees the outer envelope, so it sends it along to the right destination network. Once it gets there, the recipient just opens the outer envelope and finds the original IPv6 letter inside, perfectly intact. It's genius, and it allows the two systems to work together seamlessly. So what's the bottom line here? Why should you care about all this invisible plumbing of the internet? Well, because it's so much more than just a technical upgrade. It's literally what's enabling our future. Seriously, every piece of future technology you can think of that needs an internet connection, your smart home, self-driving cars, entire smart cities, all of it is only possible because of the gigantic address space of IPv6. Without this upgrade, innovation on the internet would have just ground to a halt. And that's really the key takeaway. This massive expansion doesn't just let us have more of what we already have. It opens the door for innovations we can't even imagine yet. We've built a digital universe that has nearly infinite room to grow. So the only question left is, what are we going to connect next?